afternoon, everyone. Thank you for joining us in this session. Our presenter is CEO and co-founder of InOrbit, Florian Pestoni.
Thank you. Thanks for the warm welcome. Turn this on. Helps. How about now? Much better. So thank you for the warm welcome. I know I'm the last show before the reception. That's hard, but keep in mind that you can have some drinks in a little while after we get through this. So today we're going to talk about how companies can survive the multi-robot warehouse of the future. I actually made a change to the title of the presentation because that future is actually already happening. Already at lots of warehouses, you're seeing very different types of robots doing different things. So we'll get into that today. But before we talk about it, let's talk about why this is important, why this matters right now. I think we don't need to spend too much time talking about how geopolitical conflict, health issues, climate change, all of these have conspired to really gunking up supply chains around the world. So, on the other hand, there's this labor shortage we keep hearing about. And what I like about this is there's an organizational consulting firm put an actual figure to that labor shortage, and it's in the trillions, right? At the same time that this is happening, the expectations from consumers keep changing. And I thought that, a lot of people talk about how e-commerce has grown, 38% over the last couple of years. But if we go back a couple of decades, the expectation for delivery of e-commerce was 7 days. So about 10,000 minutes. And now the latest expectation is when you do, fast grocery shopping, you expect 10 minutes. So the number of orders of magnitude that have changed there are significant. So with all of this, I think like a lot of people in this room today, we believe that smart robots can help. They're part of the solution. Robots are a lot more than just, labor replacement. They're data machines. So data is the thing that is really the superpower for robots. So we'll talk about how in your warehouse you can leverage data to make not just the robot smarter, but the overall operation smarter. Before I dive into this, I think it's better for you to hear from someone else. So a lot of you may be familiar, may have heard of Aaron Prater, who works at FedEx, and he has a really interesting perspective on this idea of like multi-robot warehouse.
For a company like FedEx that touches 99% of the world economy, I have so many use cases across the globe. As a manufacturer, do you really want to build my pallet moving robot and my package moving robot and my security robot and my cleaning robot? And who knows what I'll think of next what I'll need a robot for, but I'll find one. For the industry to really grow, we need to have some baseline interoperability that allow us end users to really pick and choose, and keep our operations going.
The robot manufacturers need to get interoperability addressed one way or another, either through something like what Siemens is working on, something what Florian's working on. If you are one of those companies that is on the fence, you're gonna have to pick pretty quickly, because us end users, we know where we're going. And if you're not on board, there's probably not gonna be a second chance. And I'm being dead serious.
So that last piece was at another A3 conference about 6-7 months ago, and it was interesting because here's an end user, like a pretty big one, looks, staring into the audience and saying, if you don't figure out a way to play together, maybe we won't do business together. So it was a very clear message coming from a very large end user. You heard Aaron, for example, mention the term interoperability. I've heard that mentioned many times already today. So let's get our terminology right. So the first thing is interoperability is really the technical mechanism for basically for robots to talk to each other. It's kind of setting up a common protocol, if you will, a common language. But it still like leaves us as an exercise for the reader to figure out, okay, what do you do once you have that interoperability? How do you actually make your operations better? I like this other term, which has half the number of syllables, right? So it's a little bit less of a mouthful, but it's really about how to make things work together in harmony, right? And then it's really about providing the capabilities for people to really run the robots in a more efficient manner, to define the robot behavior. So I'll talk about both in today's conversation because I think interoperability is almost like a prerequisite, right? You need to have things talking to each other before they can communicate. So let's start with what's going on in the industry with interoperability initiatives. The good news is that many in the industry have recognized that there's a need for this. And I would say even going back a few years, that wasn't the case, right? So now you have some emerging standards, as we call it. So for example, mass robotics has the AMR interoperability standard 1.0. VDA, which is an association in Europe for car manufacturers primarily, they've developed something called VDA 50/50. There are different approaches to trying to address some of the same problem, which is how do you get robots talking to each other? So far, until now, it's early days, adoption has been limited. But we're starting to see both the robot vendors, the people making robots, as well as some of the software vendors who are actually making all these things work together. We're starting to see that in the market. I think orchestration, on the other hand, is really, how do you make like real robots in the real world actually move around in harmony, as I was saying before. I don't want to make this presentation too much about InOrbit, my company, but we did launch this morning something called InOrbit Connect that we think will help with this. The key point here is companies are going to have to manage heterogeneous fleets. I was actually in the audience earlier today when the CEO of Mir talked about the different approaches that companies are following. The first thing I mentioned is Mir talking about interoperability is a great sign, right? So here's a robot vendor that seems to be signaling that this is a good thing for the industry. He talked about different approaches. One that is like centralize everything, and the other one is more like be able to leverage the unique capabilities of each type of robot, what they bring to the table, while also achieving that coordination. So again, with my orchestra analogy, I would say you trust each section to be able to play their instruments the way they should, but as a conductor, you try to get them to be in tune and create something wonderful. One of the things that we hear a lot from our customers is this need for a single pane of glass. Now, if you have one type of robot from one vendor, chances are it comes with a screen that allows you to at least monitor what the robots are doing. It gets interesting when you buy the next robot for maybe a completely different task. It comes with its own screen. And soon enough, you have different robots for different tasks. And the way to manage them is to swivel your head really fast from one screen to another, which we know doesn't really scale. So I think what is really needed in the industry is this idea of one way to at least know what's going on with all your robots, no matter what they're doing, no matter where they are. I think another limitation that we see in many cases is a lot of the technology was initially developed for a single site. So you may get a fleet management server box that comes with your robots. And that may satisfy your needs, but then all of a sudden you have 3 facilities or 20, or with companies like DHL, they have 5,000 warehouses, right? So how do you get that visibility? How do you learn from each other? And that's where my comment at the beginning about robots being data machines comes into play. All that data is data that can help you run your warehouse operations better, not just your robots better. Let me take a little bit of a step back because I think there's a deeper effect at play here. We're seeing almost like the collision of IT and OT. So traditionally, a lot of these problems have been solved decades ago with PLCs, right? You have different machines and you have one PLC that helps you control all of that. The problem is it's very static, right? So it's fine if you're creating this production facility almost from scratch. You spend months trying to optimize and program all the robots, and now you have them do everything exactly the same every time. I think that's still a valid model. But what we're seeing is now robots are first entering new spaces. A warehouse can be a much more unstructured space than a production line. You're seeing companies really try to respond to market demands much faster, so you can't wait months to rejigger your production line. You have to respond right away. And those needs are dynamic. So again, not to belabor the point about data, but if you want to be responsive to changing conditions, you need to have your robots respond to data, your processes respond to the volume of orders and so on. So that's where you were seeing a transition from traditional operational technology to information technology. And in the cloud and other areas, we've seen this specialization in the technologies to be able to work across across multiple sites. So just as an example, I used to work at Facebook, and a data center at Facebook may have 100,000 host machines, like server machines. And there's maybe 6 people that are used to supervise that. Now think about a fleet of robots, maybe in the thousands, maybe one day in the hundreds of thousands. How are you going to manage that complexity? So we need to be thinking how we bring some of the experience from some of these other areas into this. So to that point, in the cloud, something that emerged in response to those changing conditions is something called DevOps. So DevOps is combining development and operations. In the early days, pre-cloud, you would have your development team write software and toss it over the wall, and then now your operations team had to run it, and there was no communication. And you can imagine that didn't work very well. So DevOps really developed the practices and the tools to make that much more seamless and integrated. So on the other hand, you have people, right? I mean, increasingly robots are working side by side with people. You have teams that are optimizing how people work. Now we need to bring all of that together. So the term that we use for that is RobOps. Kind of like DevOps for robots, so it's easy to remember. And again, it's really the best practices for the use of smart robots at scale. To make this a little bit more interactive, I'm going to ask you to stop checking your Instagram feed for a second. We're going to play something I call RobOps bingo. Okay? So the rules are, I'm going to read a statement or a number of statements. If that resonates, if this is something that you've heard or that's maybe happening to you or to a friend, you can raise your hand and raise one finger. And for every statement, you're going to raise another finger, okay? And if all of the statements make sense to you, then you've won RobOps bingo, okay? Ready to play? All right. So let's start with this. This is about the challenges about deploying robots on a network that you don't control. Has anyone run into this problem before? Yay, okay, keep it up, keep it up. All right, one more. We have robots from different vendors. It took us months to integrate each one and then to our WMS, and now we have to start over. Anyone? Yeah, I see some fingers, yeah. Only 2 more, so your hands are not gonna die. So we have AGVs, now we're adding AMRs, and they get in each other's ways. We even have them, crashing into each other sometimes. Okay, I do see some multiple fingers, some single fingers, and then the last one. In a lot of cases, it's really not, we can't just hire enough people, so it's many use cases. We need to clean the floors, we need to run inventory. All right, so thank you. I see one bingo winner in the back, so congrats. But I think even if this wasn't exactly your situation, I think it's fine. So let's look a little bit about at a kind of like a more specific situation, right? So let's say you're a third-party logistics company or a retailer, you have very large operations. You're probably talking to a lot of robotics vendors, right? You go around the floor, you'll find robots for pallets, robots for eaches, you'll have inventory robots, cleaning robots, and so on. Kind of like going back to that statement by Aaron. Now, connecting these two things isn't that easy, right? Because there's all this like intermediate software in the middle, right? Maybe you have building management software, maybe you have customer experience software. All of this is working together, labor management, all of this is already pre-existing. So what really happens in reality is something like this, right? Have to make all of those connections. I think I'm gonna get a little technical here. So the term for this is spaghetti. Okay, it's really, really hard to maintain this. You can probably make it work for the first one. It's painful, but you got it done. Maybe you can do 2 more, but soon enough, managing all of this it becomes really complex. So that's really why we need RobOps in a warehouse scenario. Now, not everyone will be at that point right away. Not everyone is FedEx or Walmart. So what we see pretty consistently is this evolution. So you may start in like a proof of concept. You have a single robot trying to test out a particular use case. If that worked out, then more robots usually means you get more done. But you're still limited to that particular pilot site, let's call it. If that works out, then you may move on to the next level, which is now you have multiple sites. Complexity is now mounting kind of like exponentially already, because each site is slightly different, they're managed by different people, have different networks. One may be managing, large items, the other one may be managing clothing. So you start to get the diversity, but you're trying to deploy some of the same technology. It gets really, really interesting by the time you're combining tasks and sites and everything, where it's like multi-everything, multi-vendor as well. And even there, I think there's a little bit of an evolution from, how can we get our robots to just get along, right? To coexist peacefully in the same floor space. If you manage that, then it's like, can we coordinate? Can we be more efficient about how they work and operate? And ultimately, you want more complex behaviors that involve multiple robots. So you may have, a forklift, an autonomous forklift, dropping off a pallet in front of it, a palletizer, and instead of depalletizing onto a conveyor belt, you may be depalletizing onto a waiting line of AMRs. The advantage of this is maybe, perhaps you don't have the same throughput as you would with a conveyor belt, but the benefit is it's super dynamic and flexible. So as volume goes up and down, you can redeploy robots in real time. So even if you're not over there at the far end, at least we believe that there's going to be exponential growth in the number of robots, not just the total units, but also the diversity of robots. So we believe that every company with reasonably large operations is going to end up over here on the right-hand side. So I talked a little bit about these areas. So let me go into each of them in a little bit more detail. And I think with a lot of these presentations, sometimes you get like, an enumeration of complaints with no solution. So I'll try to, at least for each of these, provide some, initial first steps, some recommendations. So the first one is, as you have all of these robots operating in the same space, what we've heard from people, for example, is they've had to have a hard partition of areas of the warehouse. Which is fine if you have a goods to service area over here and packing over there, maybe that's okay, right? But increasingly as you mix use cases, that becomes untenable. So at the minimum, you need to know what all your robots are doing in an integrated way. Like if you have all those screens that I mentioned at the beginning, that's not integrated. There are some very basic things that you can do. Like for example, ensuring that two robots cannot enter a narrow hallway or a cargo bay at the same time. So you can still have each robot be completely controlled by their respective fleet management servers. You just are doing a very lightweight, kind of almost like traffic lights, but you're doing it in software, right? You don't need to install like expensive camera systems or anything like that because guess what? The robots are loaded with sensors. You just need to find a way to use them. The next one is, when you're trying to get the robots to do more complex things, and maybe you have steps that need to be followed in a particular sequence and linked together. So you can do, some high-level multi-vendor routing of robots, while still allowing each robot to use its own native navigation system. So there are companies out there that can bring all of these different disparate robots together and have them operate jointly. And then again, I think maybe the higher order version of orchestration is this idea of having robots working together. I talked a little bit about this case of like depalletizing onto AMRs. I want to change speeds for a second, change gears for a second, and talk about how do you scale and what does scaling actually mean. So here, again, I'm going to borrow from the DevOps world. There's this idea of pets versus cattle, and usually when you start with robots, they all have cute names. People hang lanyards on them, they put stickers on them. Pretty soon, they just become part of the scenery, and you need to change your mindset and treat them more like cattle, right? So again, translating this into robotics, it's not like a cute robot that waves at you. It's like, I don't want to say an army because that's scary, but a fleet of robots working in unison. So I know we have a few minutes left, so let me mention a couple of things. One is, how can you learn more about this? Right, so this is really kind of like a new practice around this idea of robot operations. And I mentioned my background is in cloud. So in the cloud, there's a role called Site Reliability Engineer, SRE, and there are conferences for SRE. So these are the people who run all the apps that you use. They're not known, they're behind the scenes, but they make sure that you have all those nines, 5 nines or more of uptime. There's conferences dedicated to that. If you're a roboticist, there are conferences dedicated to that as well, right? You can go to ROSCON, you can go to any number of conferences. We found that there was a gap in bringing people together to learn from each other around these best practices for running robots at scale. So in my case, I co-founded this robot operations group with the head of DevOps at a company called BrainCorp in San Diego. His name is Joe Mijek. And Joe was running over 10,000 robots, so he knows a little bit about scale. We're now almost 200 members. We meet monthly. And one of the things I wanted to announce, so we have interviews with great people, including that one you saw with Aaron. So you can go to robops.org and find more information. I want to announce as well, not to compete with A3, but we are trying to put together our first ever RobOps Con. So basically, it's getting people together, get some practitioners to share their expertise with others, so you can learn how to scale. And I promise not to be too commercial, but I did want to mention a little bit of what InOrbit does. So we work both for robot developers and for end users. And they have different needs. They all need data, but their needs are different. So on the robot developer side, what you need a lot of times is data from the field so that you can continuously improve your product. Without that, you think that data in the lab is useful, but then the field will teach you otherwise. On the other hand, if you're an end user, you don't need to have a PhD in robotics to be able to talk to robots. We make it very easy, and you're going to care about optimizing your end-to-end process. You're going to care about KPIs, so higher level things. So we can provide both, depending on your needs, and even the same robot could be serving both needs through what we announced today, which is InOrbit Connect. So I know we have a few minutes more for questions. If you scan that QR code, you'll find my LinkedIn profile, so feel free to connect. And we also have a booth downstairs in the startup area. So if you want to see all of this in action, then stop by.